Hello, my name's Lacey and I'm Secondary Mastery Lead for the London Central and North West Maths Hub. I'm also a maths teacher at St Marylebone School in central London. Today I'm going to be talking to you about supporting and leading online learning. I'm a maths teacher, so I'm going to be delivering this within a maths context, but I think that every aspect that I discuss is directly transferable and applicable to every other subject. So to start with, supporting online learning, this happens within a team of teachers within a department. And so I think it's really important to set the scene and discuss how we support each other when we're in school. So at our school, we collaboratively plan, and we collaboratively plan within year group teams. So all year 7 teachers, for example, come together once per week for one period. We also do this for year 8 and for year 9. These are above our timetable allocation, so these are within our freeze, but we give them up because we genuinely find them so beneficial. We would have them for years 10, 11, 12 and 13 as well, but unfortunately there just isn't room on our timetable to protect that time for teachers to come together. These do happen outside of timetable allocation. So for example, year 10 would be one afternoon after school, or a year 11 at a lunchtime, just very, very briefly. But let's focus on the ones where we are timetabled. So year 7, all the year 7 teachers, maths teachers, come together once a week for one period. We review the plans that have already been made in the previous week's teacher research group for the week ahead. And we try to plan 2 weeks ahead so that we always know what's coming up. We ensure that we cater for every student within our classes. We teach mixed attainment. So we have 5 mixed attainment classes and 1 support set. So it's really important that within our classes, we're thinking when we're planning our lessons and delivering our lessons about our highest attainer, about our lowest attainer, and ensuring that they're all challenged appropriately. And these are called teacher research groups, or TRGs for short. We've continued calling them teacher research groups, even though we're 5 years into running the teacher research groups, because we are constantly evolving, constantly revisiting the lessons that we're planning, the representations that we're giving to students. And so we are still researching, we are still learning, which is why they're still TRGs. This diagram hopefully demonstrates what I'm trying to explain. So at the top, we have our weekly TRG. We review the lessons that are due for this week, that we will be teaching and delivering this week, and then we plan for the following week. Now, we're not sitting there planning the lessons together question by question. Every teacher takes responsibility for one of those lessons, goes away, plans it in their own time, and then presents it at the TRG for other teachers to listen in and perhaps offer any guidance or questions or queries. Why is that there? What's the big idea here? And we found this to be really, really powerful. Virtually, so now we're not in school, this has continued. And actually, we've expanded it for all year group teachers. So we're not constrained by our timetables, and we are able to meet virtually for 1 hour per week per year group that we teach. We discuss feedback from the previous week's home learning, and we really take the time to reflect on this. We review this week's work, so what's coming up for year 9 this week, who's responsible for recording that video, who's responsible for the worksheet, how are we going to get the answers out, is this too much, too little? And we plan for the next 2 weeks, so we're always in advance of ourselves and we always know what's coming up. It's a great opportunity to learn from each other. This is CPD at its best, and we get it so frequently throughout the week. It's so powerful planning and discussing with your colleagues and your department about your own students and the way in which you want them to learn. It is the most important, the best CPD that I have ever attended. It's also really important. Obviously, the online learning and ensuring that our students aren't falling behind is imperative. but it's also really important as a bonding opportunity, so that as a department we can catch up together, we keep in touch, we make sure that people aren't overwhelmed with work. If someone has got a little bit too much on this week, perhaps they have extra pastoral responsibilities or something, and somebody else can say, oh, I've actually got capacity to make that worksheet, why don't we switch weeks? And it's a really, really great bonding opportunity. So virtually, we're talking about reflecting and looking at our work even more and thinking about the term coming up and how we're going to deliver content to our students. Reflection and refinement is a massive part of our teacher research groups virtually. I'm going to just run you through quickly how we were delivering home learning to I'm going to focus just on years 7 to 9, but how we were running it and how we've changed and why we've changed our online learning offer. So the first 2 weeks, everybody thought it was only going to be a couple of weeks. And so we were setting 2 topic-based worksheets, and we were providing them with written solutions. We were uploading all of this to Google Classroom, which is the platform that our school uses. And so, for example, for year 7, we gave them 1 topic-based worksheet on fractions and 1 topic-based worksheet on converting metric units. And then we provided written solutions on the Friday when it was due in. So we set on Monday, they have 4 days to complete it. They have to submit their work by Thursday evening. Friday morning, we put up some written solutions. And then as we were reflecting on this, we were thinking about our weakest students and thinking how much they're struggling with this. And we were getting feedback and student voice saying, yeah, it's great having a lot of work to do and it's great having all of this maths to do, but actually I don't feel that I'm learning anything new. And so weeks 3 and 4, we tried something different. Instead of the 2 topic-based worksheets, we had 1 video recorded lesson. We've done this in parts, so it's a playlist, so that students can do 10 minutes, and if that's all they have time for that day, that's okay. They can finish 1 video and come back to video 2 the next day. We upload all of these onto YouTube so that students can access them at a time appropriate to them. We also, instead of having a topic-based worksheet, we have a mixed topic worksheet, which is typically how we set our homework when we're at school anyway. The reason we thought this was really important was because our scheme of work in maths is a linear scheme of work. So when we've studied fractions back in year 7, we don't revisit that formally again. Of course, we'll introduce fractions in other topics, and so they do get to revisit them, but actually it's really important that we keep them on top of their key skills. And so we had this mixed topic worksheet. This was met overwhelmingly positively by students. And we talked a lot about, well, you know, recording a video lesson does take a lot of teacher time, actually. It takes a lot of planning. The recording takes quite a long time, all the uploading. There are all these videos out there already on YouTube of, you know, other maths teachers explaining in exactly the same way as we might how to answer some questions. Why don't we just put that up? But overwhelmingly, the response we got from students was, we love seeing our teachers' faces, hearing our teachers' voices, and being taught in a way that we are used to being taught. They also told us that they wanted a little bit more work. So we have gone from 1 video lesson in weeks 3 and 4 up to 2 video lessons by week 5. We were then also giving them a shorter mixed topic worksheet because we felt that it was then too much work to be learning new content and also to be expected to do your mixed topic worksheet. It's just too much for students to do at home. Home learning is not a replica of learning in the classroom. It never will be, it's not expected to be. And so that's how we adapted and made sure that students weren't being overwhelmed. However, week 5, we did unfortunately put up 2 quite long video lessons, and feedback from students was, oh my goodness, this is overwhelming. And so week 6, from week 6, so we're now in week 9 of home learning, we put up 2 video lessons or 1 longer video lesson. And so it depends on the topic that students are looking at. We're also continuing with the shorter mixed topic worksheet, but from week 6, we introduced video solutions. So instead of just uploading the written solutions, as we have done since week 1, we now have a teacher just going through that mixed topic worksheet, so that if students have forgotten, in class, it would be really organic and students would just say, oh, miss, I can't remember how to do question 3, part B, can you help me? Whereas now they can skip forwards through the video, have a teacher walk them through how to answer that question, and then they can go ahead and learn from that. And this has been met overwhelmingly positively by our students in year 7, 8 and 9. And Student Voice has said, we love the videos, the video solutions are now really helpful. I don't watch all of the video actually, miss, but I do watch the bits that I need to. For our highest attainers as well, the video solutions include challenge questions. And so they can see if they got a little bit stuck partway through a challenge, how to keep going. At Marylebone, we teach maths for mastery, and I hope that some of you will have heard of this. This poster here is created by the NCETM, the National Centre for the Excellence of Teaching Mathematics, and it contains the 5 big ideas of teaching for mastery. So around that circle, you have representation and structure. So that's about making sure that we open up the structure of the underlying mathematics to all of our students, that we give them representation that help them and can be applied to multiple topics. So it's a really useful tool for our students. Mathematical thinking, I'm a maths teacher, I want my students to think about maths, I want them to make connections between different topics. Fluency, that's about having some key facts just at our fingertips, so we're not having to worry about, oh, what is 3 times 8, but about students really deeply knowing that and having that recall. Variation, I'll talk about that on the next slide and discuss variation theory, which is a really useful way of creating questions. And then coherence is that last little circle, and that runs across all 4 of those other aspects of teaching for mastery. And that's the idea that small steps are easier to take. So we're not just saying, hey, here's a fraction, let's add and subtract and multiply and divide it all at once. It's about saying, here's a fraction where the denominators are the same. How could we add it? And just making a really small step and then building up those steps to the top so that students can then answer any question that's thrown at them. So I'm going to use this format just as we look through the next few slides and I showcase how we're delivering online learning for our students. First of all, this is one of the worksheets that I created in the very first week. It's on fractions, and the first part was about simplifying fractions. We're very aware, and we have been aware throughout all of this, about how much of a role parents have to play in home learning, and how parents actually have quite a fear of maths and really want to know the best way to support their students. And so the box that I've put at the top is both for students and for parents. I've got step-by-steps so that students can follow their way through. Parents can say, well, have you done step 1? Okay, have you done step 2? And follow the way through. And then I've also shown 2 different methods to answer this question, 18/24, how to simplify it. And so parents can see that actually if your student, if their child has done it one way, that's perfectly fine because there are multiple methods. As long as they get to the same answer, that's okay. I've been really clear to highlight the most efficient method. That's because I really want my strongest, my highest attainers to constantly be looking for the most efficient method to answer all questions. At the bottom there, question 1, you can see I've only actually put 9 questions that I want my students to answer. And this is part of variation, so that orange segment in the circle on the left and teaching for mastery. And variation theory is all about changing certain aspects, but keeping others the same, and ensuring that our students are challenged and have a step up from one question to the next. So for part A, you can see that they only had to simplify 1 common factor 10. B, I've given them a different kind of question, 22 over 22. I want my students, all of them, to know that that simplifies to 1. For C, they could answer it using 2 different methods. They might simplify it very efficiently. They might not. That's okay. And that will tell me quite a lot about my students. Question D, I would actually critique of myself now. I think question D doesn't have a place there. If they can answer question A, they can answer question D. What am I challenging there? Perhaps a better way to improve it would be to introduce some algebra even there. So 33y over 36y might be a nice challenge. By E, straight away I've introduced some algebra and it becomes more complex from there. F and G, you can see, are improper fractions, so the numerator is greater than the denominator. I'm really challenging my students here. And so even when they're at home, I am expecting my students to go deep into the maths and to really, really learn and deeply understand what they're studying. If we then look at the next one, so I've got some equivalent fractions, and if you take nothing else from today, I would love for you to take away some fill in the blanks or true and false activities. Again, I have a little box explaining what an equivalent fraction is and then showing how I expect working out to be shown. That's really clear for the students, that's really clear for parents to then follow as well. And then fill in the blanks. You can see that I'm moving around, I'm taking out different things each time, and I'm expecting students to be moving forwards and backwards. Again, I've got algebra in there early, question 4, question D, and improper fractions as well. So I'm really, really challenging my students here to think mathematically, think forwards and backwards, and expose the underlying structure of an equivalent fraction. I'm expecting fluency because I need them to know what is 4 times, what is 6 times, or 6 times what is 24? 4 times 6 is 24. I need them to know that at their fingertips. Another great aspect of teaching for mastery, and something that we include in a lot of our lessons, is true or false activities. And in those first couple of weeks where we were thinking, how on earth are we going to deliver our lessons like this to students at home, we didn't think that true or false would work. Whereas actually it's been met very positively by students, and we can see actually how deeply they understand it by how in depth their answers and explanations are written down. So I'm just going to play you a little snippet from a video. This was to my year 9, or our year 9 year group. And it is on one small aspect of maths, and it's about factorising positive quadratics. It's about 2.5 minutes long, this video clip, and so I'm just going to let it play through.
So now we're going to have a look at some true or false questions. Pause the video for 20 seconds so that you have a chance to decide whether you think it's true or false and why, and then come back. So 20 seconds, pause the video. We're looking here for 2 numbers that multiply to give us a constant. The constant is 10. So we are looking for numbers that times to make positive 10. Hopefully you identified 1 and 10, and 2 and 5. Which of these add together to give us our x coefficient? 1 and 10 is not 7. And so we're using 2 and 5. Has this person split this x term correctly? Yes, true. Here, there was only one way to split it, but there were 2 ways actually to write it, or to have written it. So we could have written x squared plus 2x plus 5x plus 10. Why does it not matter which way we write it? Because of the commutative law of addition. Next one, pause for 20 seconds, have a look at this. Here we are looking for 2 numbers that times to make positive 6. The constant, that's 1 and 6, and 2 and 3. We want to find which of these adds to make the coefficient of x. Which of these adds to make 5? Does 1 add 6 add to make 5? No. Does 2 add 3 add to make 5? Yes, it does. But what have they done here? They've used 5x and secret 1 living there. So they've done 5x add 1x. Is 5 times 1, if I'd written that here, would that work? Is 5 times 1 6? No, not at all. So we would have needed to have written x squared plus 2x plus 3x plus 6. This one was false.
So hopefully some things that you may have picked out from there were my language was really precise and using correct terminology. So although this is a new area of learning for students at home, I'm ensuring that even via video, they will be picking up the correct terminology. We've obviously discussed this earlier. I think this is the second or third video of 4, and I've already done about half an hour's worth of teaching on this. I'm not asking students to find the answer. I'm asking students just to look at the underlying structure and think about how these can go about being factorized. So how would we start? I'm making connections between different topics. You may have heard me mention the commutative law of arithmetic. That's one of the laws of arithmetic that we studied way back in year 7. So I'm still bringing in all of those aspects that we've learned previously to current new learning. Next, we have just a short snippet, 20 seconds, of a year 7 lesson that is on, I think it's laws of arithmetic with directed numbers. And so again, I'm making connections with directed numbers, laws of arithmetic for operations. And hopefully you'll see that there's some variation throughout here. If you just pause the video, we'll probably be able to see that I start with just some integers, move into some fractions, and now suddenly I have 3 numbers that I'm trying to add and subtract together. And let's have a little watch of this.
Question 4, this is where I think it really comes into its own. You say, oh, this is the point of it. This is why we're doing it. 999 add negative 20, add 1. 20 seconds. Pause the video. Try and use the commutative law to answer this question really efficiently.
So just a short video there. So this is what I call mini whiteboards, but not, because in our lessons, we use mini whiteboards religiously. Every single lesson, I will use mini whiteboards so that I can get that AFL from my students, from my class, and read the classroom. We can't do that via video. We're not holding online live lessons. And so this is the best way that we can replicate this. Actually, with our younger years, so 7 to 9, where we're doing this, we are getting a really good dialogue going between students and teachers, where students then comment on Google Classroom and say, oh, but miss, on question 4, when you did this on your whiteboard, I did this. Is that still okay? And that's really nice because that shows us that students are engaged. Students are pausing the video just for 20 seconds, very short amount of time, but they're getting that chance to have a go at it by themselves, and we're fostering their independence when they're learning at home. And lastly, I'm just going to show you very briefly some ideas of representation and how, to us, it's really, really important that our students see the same representation across many, many different topics. This is so that they have something in their toolkit that if they read a question and they say, oh my goodness, I don't know where to start, they then have something that they could try that might then trigger an idea. So these are bar models, and you may or may not have heard of these. This is just about a fact family. So 25 add what is 37, or 37 take away what is 25. 37 take away 25 is what, and how they're all interlinked together. We also use that with percentage questions. So something in a sale has been reduced by 20%. It now costs £10.40. The student can then see that 4 parts equals £10.40. So they could then go ahead and work out what the original cost was. This horrible worded question down at the bottom. Frank has 3 times as much money as Molly after Frank spends £15, Molly spends £2.50. It's such a cognitive overload for students. And so by giving them a diagram, giving them the same representation as they've seen in much easier questions, they then know or are able to start themselves. Controversially, we've got some vertical bar models here, and this is about how if we have something, we increase it by 50%, and then we decrease that by 50%. Have I got the same amount? Well, no, you can see clearly from that bar model that you don't. Ratio, and again, if we had a question to do with some money, so I have £100, I spend this much, how much is left? This is just an idea of how using the same representation across a multiple different topics makes it really powerful for students. They then have something that they think, I could try and use this in this question because I'm not sure where to start. And especially during this time of home learning, when students are having to be so independent, this is really, really important. And we're ensuring that we use the same representation across all of our different topics. I hope that's been helpful and useful. As I said, that was very math specific, but if you think about the underlying aspects that I've discussed, true or false activities, fill in the blank activities, videos with teachers' faces, teachers' voices, the teachers that they know, the teachers that they know how they teach. All of these things actually are applicable and transferable to every other subject. If you do have any questions, please get in touch. As I said, my name's Alice and my email is a.lacey@stmaryleboneschool.com. Thank you so much. Have a lovely day.